अटक गया. Oh, Korea. No, so I need that. Oh, Korea. So I went to the and that. I want to work that. Why? Or to do so, you're allowed to follow focus. Each step will consist of moving each amount of length in both the direction of either x or y axis. The first step must be along its axis, the second along y axis, third along its axis, and so on. Number of steps one will be order they are done. The odd number of steps x axis is. Each step must have a length strictly greater than the length of the previous one. Output the minimum number of steps needed to reach, or output if it is impossible. Or well, so whoa, visualize a link tab. Oh, interesting. So yeah, what we have talked about minimum number of steps, right? First of all, when it is not possible, okay. So when it is not possible, it's not possible, then we need to. It's possible in any case, unless and until the y direction is kind of same, right? Like, wait, what? What there? Acha, it should be greater. Shit, yeah, I forgot that. It should be strictly greater. Right. Okay, that's a good constraint. So, for example, I'm gonna go here and yeah, I think this. So 1 comma 1 we can't go. Basically, uh, in this y equal to mf, y equal to x are aligned. You can't go anywhere, obviously. Also, um, 1, 1 we can't go. It must be like 2 or something. Okay, if I want to go here, then, hmm, so, 2, 3, but yeah, I can't go 3. So, it's like saying I'm from 0, comma 0. Least I can kind of go is 1, comma 0. Then I can go 1, comma 2. Then I can go 4, comma 2. Then I can go 4, comma 6. One, 2, 3, 4, 5. 0, 1 comma 0, 1 comma 2, 4 comma 2, 4 comma 6, 9 comma 6, 9 comma 12, 16 comma 12. Yes. Mm, and that's what this. What can I do here? Zero. So everyone, either I'm moving one, and then I'm moving two, three. So for example, if I wanna reach here, then I can do it because here, here, and then I can reach here. Exactly, but I want to reach here. That's not possible. Right? So what, in what way can I determine it? So if I can reach here, I can't reach probably, let's say. Okay, I cannot reach any. No, I can reach. Okay, so two, then 1, 2, 3. At this point, I can reach. Uh, Here I can't reach, obviously. So here I can reach. Hmm, 2 and then 3, right? Yeah, 2 and then 3. So I can reach there. What is this I'm saying? Right. Right, sure. Yes, very easily here and here. Right, sure. Yes, here. So can I reach here then? You're saying I can reach here. I reach any point which is greater than this line I can reach because here and then here directly. It's not the same below the line because it's like the meta cover clearly you can't cover here. So the next point is point of reference is here, I guess, right? Or is it here? No, no, it's here. So from here you can go any number of points and then you can go here. It's reverse kind of, right? So this XY line then we have to follow basically. So it's can share and you can pretty much reach it, right? I guess that's true. So no, so this point basically if you check it is what? Less than this line, right? But it is it is also less than this line. So then it's feasible because once say you come here and then we have like what 12 steps here, right? And then you have 15 steps here, which is possible. Okay, interesting. So basically what we have to see is that and also if both the coordinates are same, then I don't think we can reach it ever, right? Because can't. Pretty much, yeah, because it'll never sway there, right? So, um, okay. So, well, first of all, if x equals to figure out one lesson. Continue. If x is less than y, yeah. So if y is greater, which is if it's here, then we just have to see that positive, right? Everything is positive. Yeah. So if it is above this thing, uh, y is greater than this thing. Well, then the answer simply becomes x plus y, right? Is there any other check that we need to perform? Or I don't know why I'm doing this weird continue thing. Uh, what if it's here? Then also 1, 2, 3. 1, 2, 3. Oh shit. Okay. 1, 2, 3. Okay, it's right. So okay, that makes sense. Um, if it's not, right, if x is greater than y, then we have to ask ourselves one question, whether it lies on this shifted line. So essentially what it means that whether it lies on 4 comma 5 or not or something like that. So उसमें if let's say what 4 comma 5, right? So if x minus 1 is equals to y, then no answer. Uh, Varna, the answer will be again. It's not no. Rather, if this is this thing, then it's wait. Uh, Wait, it's a number of steps. Yeah, we don't have to. Obviously, the some path will be the sum only. Nah, what am I talking about? So this is two only, nah. Yeah, and here, if you're saying like, for example, this number. Oh yeah, also another question. Another thing is that uh, it can't be less than y. Y can't be less than 2 also, right? Because yeah. Hmm. Okay. So basically, y if y is less than 2, or yeah, ठीक है. If this happens, or y is less than 2, yeah, okay, so if it's here, then, or if it's here, then same, right? 1, 2, and then 3. You can get it in 3. Yes. Continue with the 3. It's the last answer. Yeah, I've been really slow here, actually, to be honest. Oops, my bad. Okay. Pretty fast, though. Nice. So, then we have this question. You are given an integer n. Your task is to construct an array of length 2n such that each integer from 1 to n appears exactly twice. Basically, a permutation with that. For each integer x, the distance between two occurrences of x is a multiple of x. Wow. In other words, px and qx are the indices of the two occurrences of x. Then qx minus px must be divisible by x, which can be shown that the solution always exists. Oh, lovely. So, well, इसके भी visualizer link दिया है. Wow, man, today Codeforces is on fire actually. Okay, I should have. Let's say 5. Yeah, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Yeah, what will it? Damn, they've done a really good job. So 1 it will all obviously will be divisible by 2, 3, 4, 5. Okay. So if I want to make an array that's of let's say of 3 sides, so I have 1, 2, 3, 2 times. So 1, 2, 3, 4, 5, 6 is my array. 6 elements in the array. So 1 is a very 1 I can put anywhere. 2 I need to put the 2's. Or maybe let's start with 3. So I need to put a 3 in every third location. So I'll put first 3 and I'll put 1, 2, 3. Okay, and then I'll put a 2 in every 2. So 2 comes here and 1 comes here. Okay. Um, okay. Let's try this with 5, 1, 2. Or let's try this with 4 probably. 1, 2, 3, 4, 5, 6, 7, 8. So again, I have 1, 2, 3, 4. So 4, let's start with 4. 4 I need 1, 2, 3, 4. And then I need 3. 1, 2, 3. Yeah. So start with 1, 2, 3. So 8 छोड़ के मैंने we could start with something 1, 2, 3, and then we'll start with 2. Okay, let's start with 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So if I start with 7, 7, 1, 2, 3, 4, 5, 6, 7, and then if I want to make 6, I'll leave 1 and I'll do 6. 6. 1, 2, 3, 4, 5, 6. Let's do 5. 1, 2, 3, 5. Okay, the troubling part here is uh, how to um, how to execute this pattern basically. Hmm. Okay, it's a little something I would say. Hmm. Mm, I would want to. Hmm, I was thinking of adding the biggest number in the boundary, but it's uh, creating some problems. I don't know. The issue is this number is n, so it has to be like O of n. So how do I now I have to make this array in O of n? Can't be traversing it again and again because that will make it. If I have to traverse every one, if I am with at the seventh element at 7, every 7 times, and every 6 times, and every so that will become n squared eventually. I want to do it this way. How do I do that? I don't know. For example, let me just check my construction here. See, 7, 1, 2, 3, 4, 5, 6, 7, 6, 1, 2, 3, 4, 5, 6, 5, 1, 2, 3, 4, what? 1, 2, 3, 4, 5. Okay. 2, 3, 4, 5, 6, 7. Okay. 1, 2, 3, 4, 5, 6. 1, 2, 3, 5. 1, 2, 3, 4. Okay, this is hmm, where do we position which number is the problem here actually? 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. I'm able to make it, but it's not deterministically following. How do I? 5, 1, 1, 3, 4, 5, 3, 2, 4, 2. What the heck? 5, 1, 1, 3, 4, 5, 3, 2. Sorry, 2, 4, 2. Right. So It is zero then, what all? Okay, why is there three ones? That's not right. 5 1 1 3 4 5 3 2 4 2. Yep. So yeah, each one is in length. That's for sure. Hmm. How do I make it though? Let's for now, let's just imagine if they are one beside the other. 1 2 3 4 5. 1 2 3 4 5. Let's imagine they are just beside one another. 1 2 3 4 5. 1 2 3 4 5. So one will suffice anywhere. Two is not 1 2 3 4 5. Two is five distances away. Three is also five distances. Every number will be five distances away. So now, uh, hmm, pi is five distances away. So pi is sorted. Pi ka sorted. Four is not four distances away. 1 2 3 4. Four is here. So 1 2 3. 1 2 3 4. If I swap it with 3 for now, it becomes 3. Sorry, it becomes 4, 3. So now 1, 2, 3, 4. 4 is also sorted, let's say. Then let's say 3. 3 ka issue hai then. So 3 is 1, 2, 3, 4, 5, 6. Kind of sorted. But then again, it's by coincidence. So best would be to keep it at a distance of 3. So then we swap it with this 1 here. So then this would become 1. Sorry, yeah, I had the same number. 3 and then 1. So then 1, 2, 3. 3 is also correct place sorted. Then if I say 2, yeah. Here there is no basic, like here there is 1, right? So, um, yeah, let's solve 2 and 1 also. So 1 comes here and then 2 comes here. So from 2 also sorted. And 1 is anyway sorted. So the final answer becomes 1, 1, 3, 4, 5, 3, 2, 4, 2, 5. 5 is 5 away, 2 is 2 away, 1, 2, 3, 4 is 4 away, 3 is 3 away. But how is this not? It is not deterministic at all. Or is it? Wait a minute. Odds are happening first. Uh, 1, 3, 5. Then 4, 2. Okay, let me try this with 7 then. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we will start with 1. There is 1, 1. Then we need to do 3. So I say 3 here. And then 1, 2, 3. 1, 2, 3. Another 3 here. Uh, then, so 3 happened. Uh, hmm. But after leaving one space, no, no, no. The initial 3 ka one space, we do 5 apparently. So 1, 2, 3, 4, 5. 5. Okay. So then 5 का मैं एक छोड़ के 7 बनेगा थोड़ी होगा. 1, 2, 3, 4, 5. It's barely 5, right? Yeah, so it doesn't go like that. Sure. Yeah, it's just a simple observation of what I don't know. What question of that for you? Nice solution. I think pretty much it takes very easy way to show it exists. Hmm. This is tricky. I can't find a deterministic way to find it. Um, 1, 1, 3. Why are we getting this kind of a pattern of 1, 1, then 3, then 4, then 5? What happens if I put 1, 1 here? Four, or maybe 1, 5, 2, 1, 2, then 4, 1, 2, 3, 4, 3, 1, 2, 3. Okay, seems like a coincidence. 1, 1 is right. Then we do 7 because number 1, 1, 2, 3, 4, 5, 6, 7. Okay, then we do the smallest order number 2, 1, 2. Then we do 6, 1, 2, 3, 4, 5, 6. Then we do 5, 1, 2, 3, 4, 5. Then we do 4, 1, 2, 3, 4. Ah, it's locked down. Because it starts filling there also somehow. The If we are sort of spacing it equally, then the other uh, area of the area also starts getting congested. Maybe. That's not a viable option. If I start putting numbers too closely, then in the other side of the array, they also start getting closer and it creates a bigger block, which basically what seems like the issue. So I kind of have to look for an approach that doesn't place them together. Yeah, I can't understand how to do that. Mm, 1, 2, 3, 4, 4 distances here. 5. If I put a 3 here, I'm going to get 3. If I put a 2 here, can't really find out a way to, uh, is bad. Okay, this is not happening only that. If we could, let's say, मिला है so if I place a 6 here and 6 here, then if I place a 5, where do I place the 5? Or maybe after 6, let's place 2. Let's place 2. The 2 will come here very easily. Then after placing 2, this island is of size 3. So let's place 4. Because with an island of size 3, I can place 4 easily alongside of it. Then now this island will become of size 5. Right. And that is where the issue arises because size is now 5 and we need to place a 3. For 3 we need an island of 2. Don't have anywhere. Oh boy. This is so weird. Hmm. I have no idea, dude, how to do this. I have seriously no idea. It's like 40 minutes now and I have no idea. Ah, okay. Yeah, let's just see this issue. It's nice that they're giving the visualizer links for every question or not for every question. I think these are like kind of visualizable questions. Why isn't B happening? Oh God. Because I want an even sized array in which I want n numbers occurring twice. So for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I want 5 and 5. So I hmm, 1, 2, 3, 4, 5, right? No. Right. Hmm, Then we make 4, 1, 2, 3, 4. Doesn't seem like a pattern still. So if I have 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, I need to kind of do something like the middle 1, 2, 3, 4. So yeah, 3 and 3 here. So if I start here 1, 2, 3, 4, 5, 6, 7. Okay, 7. So I do 7 and 7. And then I do 6 from the opposite end. So 1, 2, 3, 4, 5, 6. And then I do 5 from this opposite end. 1, 2, 3, 4, 5. And then I do 4 from this opposite end. 1, 2, 3, 4. And then I do 3 from this opposite end. 1, 2, 3. And then I do 2 from this opposite end. Okay, this is some pattern that has been applied till for 6 and 7. Let's see if it works for 7. 1, 2, 3, 4, 5. 4 from this side. 1, 2, 3, 4. 3 from this side. 1, 2, 3. 2 from this side. 1 from this side. Okay, wait. Just simply working. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 4 that is 2. 4. 1, 2, 3, 4. Hmm. So, fine. Okay, 3. 1, 2, 3. 2. 1, 2. But then the point is still, and you know, if I were seeing exactly, uh, it still becomes sort of square, doesn't it? It doesn't actually, it is anyway, because 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. Okay, maybe then we have to play this odd even game or what? Kind of, I guess. So this is very weird algorithm starts by placing them in the middle sort of ground. Well, okay then. This is a very weird algorithm, though. I well, take, take it. Stick with the right way. So, we need twice a pen car size for this thing. Then what we need to do with that, we need to fill all the numbers. Right. First of all, I will be filling um, the largest number in such a way that it is sort of centralized. Right. So, does it work for one? This method does it? Uh, I mean, it does, yes. Right. So, here's what we will do. I will first say, um, let's say place, if we have to place that at basically n by 2. So, even with what this was, yeah, so place के left वाला number पे we have to put it. So, vector of basically place, or rather I should say, what I should say. Divide by 2 and then minus 1 also. So, यहाँ पे also 1 2 3 4 5 6 7 8 9 10. Basically n minus 2, but basically we need to minus one more. Yeah, I sure this works for everyone. Oh my God. Sorry, yeah, not 2. My bad. It was place basically. Yeah. Because 1, 2, 3, 4, 5. Wow, what are you doing? 1, 2, 3. So minus place, minus 1, and 1 for the index. This is what? This is n. Parent. Okay. This freaking magic number will be called first, let's say. Okay, so you have to place this in first, and then obviously first plus n also you put there. Can I see this? Yeah, I'm pretty sure you mess it up because for yeah, what is this? What am I saying? 1, 2, 1, 2. Places on my 2. Place minus place, which is 1. Does this make sense? Maybe it does. Yeah, probably. So this is the first step. Then the next step is let's call it num, which is n minus 1 now. So while greater than 1, we gotta do this thing, right? So this thing is that let's if count is even, what I will do is that we will go to the endmost and place num dash. Okay. So we need L also 0 and R also minus, not N minus 1, but 2 N minus 1. So then we are like, hey, if it is 0, then V of R is equals to num. V of R minus N minus num rather equals to num. Okay. And if it and also then we do num minus minus. If it is odd, then again you do this. Also, yeah, we need to do R minus 1. So for next time. So we do V of L equal to num, and we do V of L plus num equals to yeah, we need to place 1 also. So for option for auto I. ये आउटपुट ले रहा है ना. Yeah. So again, I'm not sure about whatever. Let's say let's go to late one. 1, 2, 3, 4, 5, 6, 7. So what? What does that mean? Oh wait, am I not increasing count? Yep, you're not. Oh, thank God. So 3, what is fourth one? 6, 4, 2, 8, 2, 4, 6, 1, 7, 5, 3, 8, 1, 3. Okay, yeah, it seems fine only. Let's just do this thing. Yeah, all again. Yeah, all again. And we are doing all of this in OAuth 1. Oh, sorry, OAuth 1. So, yeah. I guess it's submitted. After almost 1 hour, 5 minutes. Oh my God, this was a very bad thing. Okay, I need to. Okay, so you have you have n pods arranged in a number lines from 1 to n, left to right. Some of the pods contain flowers, while others are empty. You are given a binary string as describing which pods contain flowers and which are empty. You have some rabbits. and you want to take a nice picture of rabbits and flowers. You want to put rabbits in an empty pots, and for each rabbit, you can put it either to the left or to the right. For each rabbit, you can put it looking either to the left or to the right. Unfortunately, rabbits are quite naughty and they will try to jump and will ruin the picture. Each rabbit will prepare to jump to the next spot in the direction they are looking, but they won't jump if there is a rabbit in that spot already, or if there is another rabbit that prepares to jump into the same pot from the opposite side. A rabbit won't jump out of the borders. Your goal is to choose the directions of rabbits so that they never jump, allowing you to take a picture. You need to determine if there is a valid arrangement of rabbits such that no rabbit ever jumps. Okay. So, okay, some may see mostly. So, for example, this one. So in this one, yeah, very pretty. This immediate left right jump कर सकते हैं ना? Next spot. Yes. Okay. So here obviously this doesn't matter. This you could do left and right. You could also do right and left. Here though, um, if you do left and if you do okay, does it matter that if there is already a rabbit present in there? It matters, right? Each rabbit will prepare to jump to the next spot they're looking when they want to. If there is a rabbit already, or if there is another rabbit that prepares to jump into the same spot. Okay. But yeah, in here, if this one looks to the left and if this one looks to the right, they can't jump anywhere. And this you put to the left or right, whatever. तो वो नहीं jump करेगा ना? अच्छा हाँ तो yes दिया हुआ है, right. So the second part, yeah, okay, fair. In this one, again, no, it's no. Why is no, bro? It can be proven there is no valid arrangement of rabbits in the third test case. Okay, but why? अच्छा तो उसको उससे फ्लावर से कुछ मतलब नहीं है क्या? Probably, yeah. Hmm. प्लांट से मतलब नहीं है उनको कुछ घंटा मतलब नहीं है just hmm. So they can jump here and they can jump there also if you want to put left or right, so that's also not very interesting here. This you can prevent by making rabbits looking at each other, then nobody will jump. Here you can't okay, so if anywhere if zero is surrounded by ones, like yes. Okay, how? Yeah, I can't understand the question though now. Was there any announcement or anything? No. So what is happening? Um, for this one, I have Zephyro 101, right? So if I have a rabbit, oh, 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 okay, I got it. So If the left wala rabbit is pointed towards right and if the right wala is pointed towards left, we are planning at the same one. So, none of them will jump. But what if both rabbits want to jump into the same pot, but um they both are like the other rabbit wants to jump, the other rabbit wants to jump. So that's why they both don't jump. Can that happen? Visualizer link खोलो भाई इसका भी है. Oh, interesting. So go open this one only, and here you say R and here you say L. Hmm. Green arrow means the rabbit will jump, red arrow means it won't jump. Okay. This is L. देन रेड वाला नहीं जंप करेगा बट ये वाला करेगा. इसमें ये होगा तो लेफ्ट वाला करेगा, राइट वाला भी करेगा. फेयर इनफ. सो हाँ, इसका इशू ये है कि इसमें यू पुट एनीवेयर राइट और लेफ्ट तो करेगा जब. इसका इशू ये है कि व्हाट विल यू डू ना, लाइक व्हाट. maybe let's try this one. This is together, it's fine. जिस वो साइड में उसको साइड करा दो, इन दोनों को आपस में भिड़वा दो. इसको साइड करवा दो, इनको आपस में भिड़ा दो. फिर ये आपस में भिड़े हुए हैं, इन दोनों को आपस में भिड़ा दो, इनको आपस में भिड़ा दो. ये दोनों नहीं भिड़ा सकते, इसके लिए यस होगा, नो होगा यहाँ पर. यस. इसमें भी इनको आपस में बढ़ा दो, इन इसको साइड में दिखवा दो, इनको आपस में बढ़ा दो, साइड में दिखवा दो. दिस वन, सॉरी दिस वन, या आपस में बढ़वा दो, आपस में बढ़वा दो. ये चला जाएगा. ठीक है. ओके. So the thing is that if I have LLLL, नहीं होगा, right? Yep. If I have LLL, तभी भी नहीं होगा. If I have RLRL, RRR. So LRLRLR. Okay. So, right. So my point here is that, see, hmm, hmm, here I want to be, अरे यार, I want to be like, how do I, where is it going? How do I kind of make this possible to, if two zeros are together, right? मैं उनको भिड़वा दूंगा आपस में. If 1 0, if a single zero is kind of just on its own, if two zeros are together, then it doesn't matter. Although, if a zero is on the edge, it doesn't matter. Uh, hmm. What if I have an odd number of zeros? Okay. Odd number. Okay. Yeah. Hmm. So So far, the only problem is um, um, if I have any cluster of two zeros, if I have any cluster of, okay, let's start with two zeros. If I have any cluster of two zeros, then you can make it or not possible. If I have any cluster of greater than three zeros, you just point them towards them. So that also doesn't work like it said here. Like if you have any number of kind of this thing, right? If you have so yeah, two and greater than two is sorted. Then comes one, 1 0. So if I have 1 0, then they both are like this. This also doesn't matter. This matters. But because they're on the end, so yeah, 1 0 if it's on the boundary doesn't matter, right? So okay, on the boundary पे तो नहीं है. This would happen, but दो है, so we will make it like this, right? But I'm saying ये भी है, but I'm also saying ये भी है, right? So if there is so we need to sort of traverse, in single isolated zeros. And if that particular isolated zero has another zero, uh, then it's an issue, I guess. Something of that sort. Okay, so here's what I will do, something like this. Okay, first of all, yeah, first we can make it right. So what I will do is that पहली बात तो अगर s of I is 0, what you're considering that. Inside that, if it's a 0, okay, um, also we don't want to start with the boundaries, so we don't consider that. So now, in this case, if the previous one or the next one is also a 0, then we don't care. If Si minus 1 is a 0, or the next one is a 0, we don't care. Uh, so now at this point of the code, it means that it is an isolated zero. Okay. So isolated zero, it can be of the fish form, it can be of this form as well. Right. So now this is bad form. This is doable because the next man is right hour. So now we want to check. Let's say um, next. So next is I plus 2, right? And prev is I minus 2. Okay, yeah. So if first of all prev is greater than 0 and s of prev is already a 0, then also continue, right? If next is less than n inside bounds and s dot next is also a 0, then also you continue because it doesn't matter, right? Plus 2 you कर रहा है and that guy, if it's the same then it doesn't matter. Okay, so here tak we have reached. So I think you can just say now pro false and you gotta break and you gotta say my bad. Okay, works out. And now, are these the only cases? Are you sure? Because we only have to focus at one because if there are n number of rabbits together, they will not jump, right? If there are two rabbits, they will not jump. If there are more rabbits, they will not jump in any configuration actually. Yeah, because there is a rabbit already, right? So it will not jump. If so, two cases sorted. Greater than two case is also sorted. Yes, bachta hai only one. One quantity start and end doesn't matter, so we are not counting that. We are traversing every single rabbit. This rabbit, okay, if it's a rabbit, if the previous and the next is also a rabbit, then continue. So this basically case accounts for greater than two or greater than two zeros continue at a stretch. This is the previous one. This is the next one. Basically, एक पौधा छोड़ के. So this one, if it is inbound, if it is another rabbit. Okay, but wait a minute. What if the case is something like, this particular rabbit is not planning to come here? What if that's the case? This particular rabbit that you are taking doesn't want to come there. Basically, something like this, maybe. Something like this. So what this means is that this rabbit, you're saying you can't say L, right? Because क्या रे क्या दूं मैं इसको whatever. This rabbit can't, right? Because this rabbit will go here, so you can't do that. Then you need to do R. So you did R. But then you're like, I want to, ram it with this rabbit to make them break. This is this. But this rabbit, that's the code. The previous, okay, next also the same logic here. So if I'm at this zero, I'm like next mein hai, yes, okay, then it's not valid. Here also I'm saying, okay, previous mein hai, okay, not valid. Then here also I'm saying, what's in previous mein hai, not valid. But I'm like you this one rabbit's not planning to go here basically, right? You could just go here or some. Oh wait, okay, yeah, this will also work, right? Basically, yeah, you're trying to ram these two. You're trying to ram these two. If you want to ram these two, then the left one would be green. So this is something not our code is not accounting for, I would say, right? Um, what is this? 1, 2, 3, 4, 5, 6, 7, 10. Oh yeah. So yeah, it will give a false positive that it's valid, and it's not. It's not valid. A rabbit will jump. So, hmm. So one more thing that we need to consider here is that uh, we need to sort of fix the positions of rabbit as we go. Or can there be a greater than two wala this issue? Can it be also added to a greater than two thingy? Like um for example, if I have 1 RL 1 R. Okay, so this is the ideal condition. Okay, let me add one here. So this is not ideal now. Now, in this case, my code will again give R because ये दोनों तो साथ में है, एक दूसरे को फेस कर रहे हैं, तो ये दोनों नहीं होंगे. ये भी इसको एक छोड़ के है, so ये भी नहीं होगा, right? Because under the assumption that this is what is happening. Oh, okay, this is fine then because yeah. So this there is a rabbit already here, so this thing is fine, but this is not, right? Okay, so this one is fine, I guess, but the older one was the issue, right? So we need to sort of fix them as we go along. That where will we make them point? So hmm, wait, why is this not a valid configuration? Acha, why not valid? You mean green? Okay, whatever. Hmm. Uh, so this just made this problem very difficult, I think. So what I would want to do here is it's something like and I'm traversing it, enough. So we want to know when we are here now. We want to know whether this rabbit is looking at us or not. First of all, we have to fix the directions of the rabbits as we go along. So if we get here, one rabbit is here, okay, or let's just say that we have two rabbits like this, okay, whatever. Again, the wrong way. Yeah. So if we get two rabbits, then or any number of rabbits rather, I would just do this, right? Does that make sense though? The rightmost rabbit, actually, it kind of doesn't. Because if you want to do this, and if you want to do this, right, fine. But, imagine if this wasn't an even number, right? Or odd number, whatever. So if you want to make sure, it would still work out, right? So that's the issue here, actually. That you can't basically do this. You can't basically do this. So, hmm, um, this is the main issue here. What we should look forward to is that um, RRR. If we get three of the same ones, basically, So we can, we need to, right? Because if I don't, so that is based on the assumption that there is no, yeah, there is no one there. Okay. Just based on the assumption that you go here and there is an R here, or L here, and the L points here. So, cause the L points here, cause the L points here now, uh, we need to need to change this. See, we can't make, let's try this out. So we can't make this L, right? Wow. We can't make this L. So we make it R. Okay. We can make this L. Uh, uh, hmm. Let's just assume all by default, something like that. So we make this R. Okay. This one, I could make it L. Mm-hmm. So I make it L. This one, could I make it L? Yes. This one, could I make it L? No. So could I make this R? Or could I make this R? Yes, you can. Hmm. Putting all of this doesn't exist. This L. Let me make this R. What just happened? You're saying the solution is right? It's not. It's really not. This is dependent upon this. It still doesn't solve this one. कि इसको मैं R करूँ, इसको मैं L करूँ, तो ये किधर जाएगा? Okay, first I think to solve this problem. Hmm. So, uh, if we encounter a rabbit, we could say L or R, right? L movement is the फायदा नहीं है. So we say R. Then we go to the another rabbit. Uh, that rabbit would be L or R. Yeah, so we can't say R. We don't know about R. We can say L. So I say L. Then another rabbit. Brain is fogging at the moment. Hmm. How do I think it through? I don't get it. If this is an R, this is an L, this is also an L, then work out, but if I'm here, I can't say this to be an L. I can say this to be an L. Do I have to say this to be an L? Yes, for this to be uh, valid. Right? But how does it matter when there are multiple, right? Then this would matter because then this can change to L and this can change to an L as well. So double affects it definitely. But so now if you're starting, let's say, then I'm like, can this be L? No, it has to be R. Okay. Can this be R? I mean, it can be an R. It can be, uh, actually, it can be an R, it can be an L. I don't really know, but L, so it definitely can be, right? Can can be a good state. So L it can be. R it can. This guy, can this be L? Yeah, it can be L because previous one is any, so this can be L. But this can also be R, right? It can be. So this is also any technically. Then this one is what? Can this be L? This one can be because this is technically any, and this is also technically any. So okay, what? So it can be L, but then this will have to be R, and this will have to be L. Okay. So this is also any, and then it finishes. So we haven't gotten a discrepancy yet, right? But if we do this, let's start with this. Let's start there. So this, can it be L? Can it be L? No. It has to be R. Okay. This guy, can this be L? It has to be L. Okay. Can this be L? No. Can this be R? Discrepancy. I see. So then this would make things a lot more complicated. You can't simply check for this condition, right? Yep. Okay. So, hmm, mm, Are you sure we're not missing something here? Definitely not. There is no way. Right. So, first of all, this is not that easy, right? So, we kinda need to start from here, I guess. And if it's a zero, then you have to be like, uh, hmm. So we have to check if can it be L, can it be R? If both, then let's call it any. Okay. So, hmm. Uh, so how do we check if it can be L? Okay. So let's just write it here. Checking, let's say L possible. Okay. We need to check whether L is possible or not. So, hmm. Now how do we check whether L is possible or not? L by L possible or not, meaning can the rabbit be made, can it be made to face left side? Okay, without jumping. If I is zero, yeah, should I say something on this? L to R to, I guess you could. Uh, let's see what happens here. So if L is zero, sorry, I is zero, then L is possible. If it's not zero, obviously, most of the cases, then we have to check whether the previous guy, like for example, um, yeah, so mm, um, if the previous guy is a zero, okay, अगर वो है तो वो कर दो या फिर if s minus 1 is also a zero. Hmm. Should we make another array for it? I think we can make another array for it. Okay, let's make the vector string. It's a direction. Okay, so yeah. So yeah, if it's a zero, then L is possible. If the previous one is a rabbit, then also making the rabbit face L is possible. What is not possible if there is a one, right? So we come here, we say else. No, wait a minute. This the previous one is that this thing. उसमें also we have to check whether ये है तो नहीं है क्या है Okay, I think I should just, divide this into this one. It's gonna get super complicated. So if Si minus 1 is 0 and true, else if it is a 1, okay, then if I minus 1, okay, so we say a prev, which is I minus 2. If prev is less than, if prev is greater than 0, and direction of prev is any, direction of prev is any, it should also be a this thing also now before constraint there. If S of prev is a 0 and direction of prev direction of prev is R, या फिर direction of prev is any. If prev is greater than 0, prev is it's 0. If the direction is right or the direction is any, then L is positive. Else, L is not possible. Right? I think so, yeah. I think that probably covers all of them. Ouch. The previous one was 0. Uh, true. This is the two previous one. And if it is greater than 0, and अगर है ही नहीं पॉसिबल ही नहीं है तो देख इसका मतलब प्रीवियस वाला 1 है. अगर प्रीवियस वाला 1 है एंड अगर ये नहीं हो रहा है नहीं कर सकते ना. एंड अगर वो भी 1 है तो भी नहीं कर सकते. एंड अगर rather you could sort of simplify this to L नहीं है. Direction of previous, sorry my bad, direction of previous is not equals to R but not equals to L. ठीक है. अगर वो L नहीं है any है या R है तो कर सकते, वरना नहीं कर सकते. ठीक है. I think it kind of makes it a little weird, yeah, but so R कब कब possible है. ठीक है. So if I is n minus 1, then obviously R is true, bro. But इस पे आते हैं फिर. ठीक है. If S of I plus 1 is a 0, आगे भी रैबिट बैठा है मतलब चल बैठा सकते हैं. बट फिर आता है नेक्स्ट पे, सॉरी माय बैड. Next is I plus 2. If next is less than n and S of previous is a 0, sorry, and direction of next, sorry, if direction of next is not right, then R बिठा सकता हूँ मैं, वरना तो भाई R नहीं बिठा सकता। ठीक है, yep, ये हो गया। Yes. So now we come, I come, and now we come and we're like, if L भी बिठा सकते हैं, R भी बिठा सकते हैं, then direction of I is any, else if L, direction of I is L, else if R, direction of I is R. कोई भी नहीं बैठा सकता। Okay, first break. Oh my god, that is a very weird code. Okay, with a weird thing also. What happened below? Okay, there is an error only here, apparently. I saw. Okay, it's next field. I copied everything. Oh my god, we get the right answer. But we get yes for this also. Wonderful. Why are we getting yes for this? I don't know. Can I get the directions? Wow. Yeah, why are we not doing anything for these? Are we not? Okay, काम को break मत कर. Answer is still the same, but just break मत कर. Okay, just this is not. I don't like this. What's happening here? Doesn't make sense. Can we just get a this thing because it's getting very confusing. Okay. So, okay, yeah. Okay, that makes sense. For all the ones, we will get that only. But, so what happened here then? One, two, three. One, two, three. Yeah, why are all ones below? Yeah, that's weird. Although it's a no. So what? Yeah, yeah, true. Yeah, so this is something not right. Yeah. Although, yeah, you could say this then, right? Like, maybe that's why it's happening. Date of, I mean, this is not gonna solve anything, but at least this will be like, whatever, something. Yeah, so, यहाँ पे X आया. Okay, for both of those ones. यहाँ पर X आया. यहाँ पर any बोल रहा है ये. How can it be? Okay, wait a minute. Yeah, so let me go back here. 1L, 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 1. Okay, yeah. So we come here and I'm looking at this one and I'm like, where are my conditions? L possible, like, yeah. I'm like, uh, 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 yeah, so I think any, we are sort of using any as a like a quantum state. दोनों में दोनों possible है, which you don't have to do. The ideal thing to do here would be to um, hmm. So for example here can L be possible? No, because पीछे वन बैठा हुआ है ना? So यहाँ से ही हो जाएगा, ठीक है? So R ही रखना है इसको, which is true. R ही रखना है, ठीक है? Then हम आते हैं इस वाले पे। तो अब ये बोलेगा भाई कि देख, इसमें L में रख सकता हूँ, ठीक है? R में रख सकता हूँ क्या? R रख सकता हूँ क्या मैं? ओके, यहाँ पे एल में रख सकता हूँ, यस। आर का सीन है कि आर में रख सकता हूँ या नहीं रख सकता। Why do I think it will form a chain reaction going backwards? Well, it's just a easy question. Uh, L will be like uh, L is definitely possible. R is I mean how can you even check this, right? This is stupidity, right? This is stupidity. You can't do that, right? Um. So mm, I think we need to resolve all the you know all the any's. Only then we can get to the answer. Also, wait a minute. Um, what if this condition that you're saying? What if there is one more? ये तो फिर ठीक हो जाएगा. Okay. Uh, what if there is one more? Oh my God. So does this simply mean that we have to check whether there is, this odd number of rabbits? Like, because here there are six rabbits, so six rabbits are fine, but five rabbits are not fine. Yeah. So, hmm. Are you sure there is no other? Not very sure of it, but um, इन दोनों को मैंने बढ़ा दिया, इन दोनों को मैंने बढ़ा दिया, मान लेते हैं, इनको बढ़ा दिया, इन इनको बढ़ा दिया, इनको बढ़ा दिया, what the fuck, इनको बढ़ा दिया, इनको बढ़ा दिया, sort everything. Hmm. So what you're saying is that 2 is not interfering anywhere. This is on its own independent thing. We just need to look out for odd wala thing. Yaar, then to... Okay, you know what? I'm just gonna copy it, paste it into because if that doesn't work out, here we just probably have to go back to the old code. Oh my god, there. I have to write it again. Lovely. So yeah, it wasn't that difficult, I would say. But it's really uh, cruel. So yeah, if first of all we start from here and we go till here, and if s of I is 0, or rather, do this. Okay, now um now you'll be like, if s of I minus 1 is also 0, we have to know s of I plus 1 is also 0. You continue because double, right? So double or more double. The other one is basically checking the next and previous file, I think. I minus 2, next is I plus 2, if previous is greater than 0, and as dot graph is 0. Uh, um, Continue if next is less than n, and s dot next is also a 0, also continue. Yeah. Mm, Varna, okay, false. Break. Right. So here it was giving the same answers, still giving the same answer. Now we just need to count apparently the number of uh, these kind of occurrences, right? So how do we count this? Uh, um, if we get uh, if the number of ones or zeros, increases by 1, uh, put the counter to 0. How about that? Basically, you want to find the length of the longest, this 101010, something like that. Okay, there's one more thing, whether 1, 2, 3, 4, 5. And this would be fine, right? Yeah, basically it would be. The thing is, edge wala मैं कहीं भी use कर सकता हूँ. So I don't think it's a big deal. Even if this also goes now, it's not a big deal. I can use L on the. Okay, yeah. So it's not. It's not. I don't think it affects. Right. So um, the point is that we need to count number of 0, starting and ending at 1. That's what I need to count. Um, to do short. Um, so I is 0, 0 plus 4 plus if if 0 greater than 1, yeah, or 1 greater than 1, then we need to sort of check something, and that check will basically be that uh, wait, what the hell are you checking? I mean, okay, my brain is so fogged and I can't even. So I need to check the number of the length of the maximum 101010. Right. So one thing would be if it starts at 1, you start the whatever counter thingy and you keep alternating it at every index. If it matches, you add. If it doesn't match, 1, 2, 3, 4, 5, 1, 2, 3. Yeah. If it matches, you add. If it doesn't match, you don't. Basically reset it to whatever. If it's 1, you reset to 1. So, okay. Basically, let me just call this total length and something like state false. Oh, no, state actually. I need to match it with true first. Okay, so if basically if S of I is equal to the state now, then you do let's call this len. You do len plus plus and you do state equal to not state. Okay. Yeah. उसमें भी होगा उसमें भी होगा उसमें भी होगा उसमें भी होगा उसमें change होगा उसमें change होगा and then you'll get your length whatever it is, right? So we need a max len also, right? That's what we need to check basically. So max len is basically max len comma len everything. No, but that also at the expense of, let's just say, it doesn't match. Should I say that? Or rather, okay, let's just do that one. If state is 1 now, state to change that as well. If the previous state was 1, that means, before turning, if it was 1, then you do max len, or max len. Okay. What about this? If it doesn't happen, then if S of I So if current is 1, uh, len is 1. You know what, bro? इसको बाहर रखना चाहिए अपने को। यहाँ रखना चाहिए। इसको स्टार 0 से करना चाहिए। एंड तो इसकी ज़रूरत नहीं पड़ेगी। सॉरी, नॉट की ज़रूरत नहीं पड़ेगी। ऑल्सो if current is 1, then length is also 1. And state is also 1. But अगर current 1 नहीं है, length is 0. State is 0. Just TVG the max length. 7. Okay, 1, 2, 3, 4, 5, 6, 7. Yes, 7 indeed. Also, yeah, so इसमें we get max length 1, which is fair. इसमें we get max length 3, which is this one, fair. इसमें we get max length 1, 3, sorry, 1, 1, 1, 3, 1, 5, okay, 5 and I guess 1, 3, 7. Okay, it works. It works. Now, the thing is that if I divide 7 by 2, I get 3. If I divide 5 by 2, I get 2. So basically, first of all, maximum will always be odd. But if maximum divided by 2, तो अगर 2 से divide करते हैं, and 7 divided by 2, 7 modulus 2 does mean, sorry, not 7. 7 divided by 2 is 3, and 3 is odd. Then it's bad news, right? Basically, I want the number 2. Yeah, the number of rabbits in it. Right, so if it's all rabbit, then no. अगर 5 होएगा तो एक और बढ़ जाएगा, right? Then divide by 2 will be 4, I guess. What the hell? If this happens, then if okay, only then. Okay. If okay, and अभी तो फर्क क्या पड़ता है? Okay is false बोलना सीधा. Hmm. बोला अभी भी नहीं चल रहा है यार ये. Okay. We have some broken ass logic for this. Uh, so yeah. Uh, I I highly doubt it's gonna work because lot of edge cases, like lot of hardcore ish schemes exists. So yeah, um, but I guess the logic was sound for if there are any other ones here, right? Or not just that, maybe like for example this, but for example let's say this, right? So what I'm saying is that if we do this, right? But then just add a little padding also. Yeah. So see, this you can't, this you can't. Again. So here basically what happening is that this I don't consider at all. In the end, what I get is that uh, मतलब वो है, इसके भी है, so this also gets a clean sheet. But in the end, I'm like, what is the longest 101 chain? Get this one, which is odd number chain. So I know it work out. Is there any way to work this out? This has to be left, this has to be right. If you change this to right, this doesn't work, so this has to be left. This you can change it to right, this you have to change it to left. If you change it to left, oh my god, it works. Oh my god. Oh god, it works. It works. We are wrong again. Lovely. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Who's gonna say no? Said nothing. No, indeed. But it is yes. So now, um, so now you've uh, gotten stuck again. Hmm. So basically now apparently what it feels like. The thing is that अगर ये अलग अलग होते हैं uh, then ये इवन होगा ठीक है बट ये साथ में थे इसके लिए ये ऑड हुआ ठीक है What if there was one more time? अरे यार damn it ठीक है भाई खुद ही कर लेता हूँ मैं if it was like this okay then it had to be L this had to be R right this had to be L this had to be R this had to be L and sorted okay yeah so in this case yeah so in this case we have 1 2 3 here and 1 2 3 here so 3 as we found out odd number of rabbits not good apparently it was but here it's not the case odd number here odd number here both अपने आप में they can achieve right odd plus odd is even Plus one is also odd, let's assume. But yeah, it doesn't work out. Yeah, so my head is fried. And probably, I don't know, this was just uh, very bad contest. And